Welcome to PDMA Corporation, home of the MCEMax. I'd like to thank you for joining us as we continue along in our presentation series. Once again, we have the Vice President of Product Development, Mr. Noah Bethel.
Hello from sunny Tampa, Florida.
And I am Todd Gunderson, the Vice President of Sales and Marketing. And Noah, our customers have come through for us again with a DC Armature failure, grounded insulation. Well, this is we've gone through this quite a bit, but there's some really interesting things about this case study that I think you would find interesting as well.
Yeah, I always like looking at DC armatures. I've always said they're the best motors to troubleshoot because you actually can, send signals onto the armature and to the field separately. So always like the DC troubleshooting.
And if my voice is a little hoarse and raspy, I was at the hockey game last night. We were hooting and hollering, and I'm sure you're going to go tomorrow night.
So you're fresh off of a playoff win. That's a pretty big deal. What a great sport.
Those are exciting times when the playoff games for sure. So I might be a little bit hoarse, but good thing we're not doing this on Wednesday because usually you come in very hoarse. So
yeah, a lot of yelling going on.
Well, Noah, this is, like I said, this is a pretty good size DC motor.
Yeah, class 250 horse. This is obviously a workhorse somewhere. The DC motors, although they're being replaced, gradually with
they're still there.
Frequency. Absolutely, they're out there. They're doing a very important job, and almost anywhere we find them, the job is very critical to the application, to the plant.
Right. So here's what this motor is: a stamping press. It was running normal with no trouble calls. So
always.
You expect it to start back up when you go on to the next shift. The plan was to restart the reliability testing program to test all large critical motors. I wonder why that is. What drew that plan to change? And we're going to show you some data that might be interesting for you to look at. First test on stamping motor showed excessive leakage. Problem must be with the tester, right? Because we're just starting this up. It's got to be an issue with the tester.
Very common to test, to question the equipment if you didn't expect that failure. So it must be something else going on.
So they ran the test again, and same results. Got to be the tester, but then they went to their sister motor and they received the expected results. So it's not a tester issue; it needs to be probably it's a motor, potentially a motor issue. So here's the actual information, and you can see here we've got a large history of data.
This is a great amount of history that we don't see very often.
And what I'd like to point to you is really consistent testing up until 2007. And look here, even in 2007, you can see a low resistance to ground.
Yeah, and this is very common with DC armatures. There's a lot of carbon dust floating around, on our submarine. It was very normal for us to, weekly get into our 300 kW motor generators and having to blow low pressure air to remove that carbon dust. My guess is that 0.7 megohms, on the 2007, measurement was exactly that. Ground it, they were able to identify it and raise the value to an acceptable, over 100 meg.
Yeah, and they may have blown it out, whatever the situation was, to get it cleaned, and then they brought it back into operation again. And this is an excellent point, that if you look here, we went from 2007 and we stopped testing until 2021.
That's a big break.
That's a huge break in testing, and we see it a lot. Maybe we weren't highlighting our finds. We weren't tooting our own horn, as we like to call it, when people are down here at our classes and we always recommend that if you do find something, let the people know, because the reliability is sometimes just seen as an expense, right?
Right, and we had a tip of the week sometime in the past called justification, and it's exactly right.
Yeah, you don't want to be seen as an expense.
Exactly.
Not to the organization. You want to be seen as value added. So now you can see here. Now, Noah, explain to us, we've seen this quite often, this bathtub curve here, that kind of explains what may have happened in this case, where they went full testing until 2007 and then they just stopped.
Right. So what's interesting is I like what you've got written in red here on the failure rate side, which is the infant mortality. Anytime there's a new application installed, or anytime you open up a system and go in for investigation purposes or just a visual, you always stand that chance of that infant mortality, high failure rate. In the Navy, we used to have this checklist, right? If you went into a turbine generator, you had a list of any tool you went in with because you didn't want to leave it inside there. That falls into the infant mortality. Unfortunately, or fortunately, if you get past that, you get into that low failure rate, and that's where you don't always see a lot of return on the work you're doing and the trending you're doing, but nonetheless, that's the low failure rate, and that's where we all want to get.
So by utilizing our technology, what we're trying to do is just really identify these issues before they become early infant mortality. Like, for instance, do a QA check on that motor before you get it.
Absolutely, the QA is the right starting point. Get through that infant mortality stage as fast as possible, and let's move into the high reliability element of the bathtub curve.
And then when you start to get into the wear out failures, that's really the trending side of it, is to try
Absolutely.
and find these issues early before they become these big uglies, as we call them, and costing you a lot of downtime
Right.
and a lot of extra money, to the point where in 2021 now they want to start testing again. So what drove that decision to get back into testing?
Unfortunately, you and I have both seen too often a catastrophic failure that reintroduces in a hard way
Somebody asked the question, did we know this was going to happen?
a need for reliability.
And so that usually drives it. So we're getting back into the data again, and you can see the DC Armature PI test trended. It really comes down to a fairly low number, right?
Very low. That's we couldn't even calculate it.
Right. And so we come in, and this is a graph, 0.1 megohms.
The equipment is obviously tripping on an excessive current level, and for protection of the system and the equipment and everything, they don't want to be sending that DC current through for any extended period of time. So very low.
Very low. Now, and if I come over here and I look at the field, it looks pretty consistent to a field. The resistance ground is fine. And also the polarization index on that field.
Yeah, that's a good-looking polarization index. It's rising gradually to an acceptable high value.
So another thing about this, there were additional issues with this. So, okay, we figured out that this motor was actually grounded, and it had to do in the terminal connections, and they saw the arcing of it. And they made the repairs to it, and they went to go start it back up again, and they found out they couldn't get the correct oil pressure, so it had a lube oil pump that was associated with this. They investigated to find the lube oil pump had been spraying oil in a closed location, and it essentially was spraying oil not only on the pump itself, was called the failure of that. Obviously, there was a lack of containment, so there was oil going everywhere, but it also seeped into the motor.
Imagine that.
And the seal tight and the insulation actually failed there, so they actually had to get a brand new motor as well.
And imagine how long before 2021 was this occurring, and could we have identified on a trend?
Could have even been a fire hazard.
Absolutely. And
When you have spraying oil, that could be a fire hazard. So there are a number of issues that may have been able to have been solved if you don't delay or you abandon that reliability testing program. And in this case here, $60,000.
Yeah, absolutely. Yeah, fix the small problems during the reliability stage, so that you don't have to have the big expenses like you see here.
Right. So savings of $60,000, cost of $60,000 may have been saved if they would have just kept that testing, even though they weren't seeing the type of payback. But like we said earlier, you have to really accentuate or let your successes be known to the outside of the reliability.
Justification.
Justify what you're doing. Well, Noah, thank you for your intellect on that and giving us the information that you provided to us. And as well, thank you for your time, for listening to us. And we hope that you took a little bit out of today, right? Just a little bit, and to make yourself an easier tomorrow, or a better tomorrow is what we like to say. Until the next time we get to talk to you, have a great day, a safe day, and we'll talk to you real soon. Thank you.